Ever felt like you're just sort of guessing with your AI? Tinkering, adjusting things, holding your breath, just hoping it's actually getting better, hoping it matches what you envisioned. What if we could move past that intuition, past, I think this is better? What if you could say, I know this is better, and here's the data, the actual proof to back it up?
Yeah, ditching the gut feelings for cold, hard facts. That's really the superpower we're diving into today. It's a fundamental shift, actually.
Welcome to the deep dive. Today we're unpacking a really crucial topic: how to evaluate your AI workflows, specifically within environments like n8n and moving away from those subjective feelings towards objective data-driven decisions. This isn't just about small tweaks. It's about building systems with real precision, a much more reliable approach.
hmm We're going to explore why traditional testing methods often fall short when you're dealing with AI's unique complexities. We'll definitely get into the critical importance of what we call a gold standard data set and walk through some really illuminating real-world examples so you can see this in action. And then, yeah, give you a step-by-step guide to setting up your very own evaluation system.
Think of this deep dive as your personal guide, your path to becoming a workflow wizard, someone who crafts solutions with proven precision, not just someone who, well, tinkers and hopes for the best. It's a game changer for how you approach automation and what you can achieve, really. So let's start with maybe a stark image, one we're calling the medieval doctor problem. It's about why, for too long, many of us have been kind of flying blind when it comes to optimizing AI. You know the drill. You build an AI workflow, it's not quite right. You think, okay, if I just change this one thing, maybe it'll get her. So you change it, you run it, and then you just sort of feel if it's better or worse. You repeat this loop until you're either totally frustrated or you just settle for good enough.
It really is like that medieval doctor prescribing leeches. Lots of confidence, maybe, but absolutely zero data backing up the decisions.
Exactly.
And that's such a perfect analogy because, in the probabilistic world of AI, your feelings can genuinely deceive you. And the problem with that guess and check approach just leads to wasted time and, honestly, unreliable AI outcomes. Decisions aren't based on facts, they're based on subjective feelings, which, well, we know are notoriously unreliable with AI output. Workflow evaluation, though, that offers objective proof. It tells you exactly what works and what doesn't. It turns those educated guesses into properly informed decisions.
So why does this guess and check approach really hinder progress in AI?
Well, simply put, it leads to wasted time and unreliable AI outcomes because decisions are based on subjective feelings.
Okay, let's unpack this a bit more. The difference between testing traditional code and AI is absolutely fundamental. Think of it like a glass box versus a black box. Traditional code is the glass box. It's deterministic. You put 100 identical inputs in, you'll get 100 identical outputs every time. You can see everything, know exactly how it works. It's transparent, predictable.
Right, but AI models, they're the black box. They're probabilistic. Give them 100 identical inputs, and you might get 100 slightly different nuanced variations. It's kind of like asking 100 different human experts the same question. This complexity comes from evolving models, that inherent probabilistic nature, and the fact that you're often optimizing for multiple goals at once, like accuracy, cost, speed. Because of all this, you really need a full dashboard of key dials. Think of it as performance for accuracy, reliability for consistency, efficiency for speed and cost, and then quality for that sort of subjective goodness.
So if AI is this opaque black box, why is isolating variables so crucial for testing? How do we even figure out what's working?
The golden rule. It's truly the core of scientific testing here. Isolate your variables. Think about it. If you tweak the prompt and change the model and adjust the temperature all at once, then maybe your accuracy goes up great, right? But you have no idea what actually caused that improvement. Was it the prompt, the model, some weird combination?
Right, you're lost.
Exactly. Isolating variables precisely identifies which specific changes improve or harm your workflow's performance. Otherwise, you're just guessing again. Now, what's really fascinating here, and maybe the absolute foundation of this whole process, is your gold standard data set. This is your source of truth. And honestly, your evaluation is only as good as the data you feed it. A brilliant test system with, well, garbage data, it just produces garbage results. Simple as that.
I remember struggling with that, trying to convince stakeholders why building out a really robust test data set was worth the upfront effort. It felt like extra work then. But it truly is the bedrock, isn't it? Your evaluation data is like your perfect measuring stick. So what makes a good gold standard data set? Well, it has to be accurate, obviously, with undeniably correct answers. Consistent, so no contradictions in there. Comprehensive, covering every scenario you expect. Representative of real-world usage, that's key. And crucially, full of edge cases, those weird, tricky examples most likely to break your system.
Well, the edge cases are critical.
I've seen workflows handle 99% of inputs perfectly, only to completely fall apart on one unusual phrasing, those edge cases. They're gold for finding the real weak spots.
Exactly. And where do you find this data goldmine? Often it's right there in your own company's history. Think about high-quality support tickets with perfect resolutions or expert responses to common questions. Even top-performing marketing content could be useful. But honestly, the absolute best source for validating both your test data and the AI's output quality, your subject matter experts. SMEs, the people who did the job manually before the AI. They know the nuances.
That SME connection is truly invaluable. But then the question always comes up, okay, how much data is enough? For early testing, maybe 50 to 100 examples are a decent start. Get your feet wet. For production readiness, though, you'll probably want 250 to 750 examples for statistically significant results. And for those really mission-critical systems where accuracy is just non-negotiable, you're looking at 1,000 examples, maybe more.
Big numbers sometimes.
Pro tip here. Start collecting this data months before you actually think you'll need it. You will thank yourself later.
Definitely. So what's the biggest risk if your gold standard data isn't truly gold?
Well, flawed data doesn't just give you bad results. It gives you confidently wrong results. You end up building your whole strategy on quicksand, thinking you're making progress when you might be optimizing for the wrong thing or maybe even making things worse. It leads to misleading evaluation results and ultimately just bad decisions. All right, enough theory for a minute. Let's get our hands dirty. The best way to understand this power is really to see it in action. So let's walk through a couple of real-world n8n evaluation scenarios. First up, imagine an email tagging agent. Goal is simple. Read incoming emails, tag them with a specific category and a priority level.
Okay, so the setup for this experiment involves a test data set. Let's say just 6 emails, each with a known correct category and priority. Then we use n8n's evaluation nodes, which are like these pre-built components designed to compare AI output against a correct answer, to run the test and measure the results against those known answers. Pretty neat.
And the first run reality check was, well, a bit of a disaster, honestly. Priority accuracy was mediocre, maybe 57%. But category accuracy, a big fat 0%. 0.
Wow, okay.
Now, the diagnosis was immediately clear. The AI had no system prompt to guide it at all. It was just making up its own category names, like billing issue, instead of the required category billing. So every single category test failed because of this, well, fundamental oversight.
Right, makes sense. So a simple fix then probably made a huge difference.
Monumental. A clear system prompt was added to the AI node, giving it a constrained list of the exact categories it was allowed to choose from. The final results. Category accuracy jumped from 0% to a perfect 100%.
That's amazing. 0 to 100.
It really highlights how the simplest, most systematic fixes, discovered through evaluation, can have the biggest impact. It's often not about super complex engineering. It's just about clarity and constraints.
Totally. So, okay, second example, a bit more complex, the FAQ response agent. The goal here is read a customer email, find the relevant info in an FAQ database, and then craft a helpful natural language response. The big challenge here is that the output is subjective, right? You can't just check if 2 long paragraphs of text match exactly. How do you measure things like helpfulness or tone?
This is where it gets really interesting. How does using a second AI as a judge help with those really subjective tasks?
Well, the solution is using a second AI to act as an impartial judge. You feed this evaluator AI the original email, the known gold standard answer from your test set, and your agent's generated response. The evaluator's only job is to provide an objective, quantitative score, say, on a 1 to 5 scale for the quality of the agent's response. It provides an objective, quantitative score for quality where exact text matches just aren't possible. It's a super useful technique.
And this led to a model showdown with some surprising results, didn't it? The initial hypothesis was something like, Google's Flash model will be faster, but the more expensive GPT-4o Mini will be more accurate. Makes sense on the surface.
Yeah, that was the guess. But the data delivered a twist. GPT-4o Mini scored a pretty mediocre 3.5 out of 5. And yeah, it was slower and more expensive. Google Flash, on the other hand, delivered a much stronger 4.3 out of 5. It's like a 23% improvement in quality. Plus, it was twice as fast and significantly cheaper.
So the verdict was clear then.
Crystal clear. The cold, hard data proved that the cheaper and faster alternative was actually the superior choice in terms of quality. Without the systematic data-driven evaluation, most people would have probably just stuck with the more famous, more expensive model, assuming it was good enough. This shows a real, tangible, competitive advantage you can get from evaluation. Mid-roll sponsor read, provided separately.
So you're probably sitting there wondering, okay, how do I actually set this up for myself? We've designed what we call a final exam system. It's a practical 4-step guide to building your own AI evaluation setup. Step 1, design your exam paper. This is your test data set. You'll create a simple Google Sheet maybe with clear columns for your input data, like the email body you want to test. And the expected correct answer, say, the specific category you want the AI to output. Keep it simple.
Right. Then step 2 is building your testing room using n8n's evaluation nodes. The workflow is pretty straightforward. An evaluation trigger node loads all those test cases from your Google Sheet. That data then flows through your AI workflow to get processed. Finally, a set of evaluation nodes records the AI's actual answer and directly compares it to the expected correct answer from your sheet. It's basically setting up the proctors for your AI student's exam.
And for step 3, you run the exam and analyze the grades. When you execute this evaluation workflow, n8n provides a really detailed report card. This includes the overall accuracy percentage, a breakdown of performance on each individual test case, and other key metrics like execution time and API costs. It's all right there, laid out for you. Actionable information.
And this brings us to maybe the most critical step for long-term improvement. Step 4, keeping a lab notebook. You know, a good scientist always keeps a detailed log. You should create your own testing log. Maybe a Google Sheet or Notion page works great. For every single test run, document what you changed. The prompt, the model, the workflow step, whatever, why you changed it, what was your hypothesis, and then the final results. The new accuracy, speed, cost. Honestly, this documentation is pure gold. I have to admit, I still wrestle with prompt drift myself sometimes. Or I accidentally change some tiny variable I didn't mean to, and then my results are just chaos. But the lab notebook always brings me back.
Prompt drift. That's when even a really subtle change in your instructions can completely alter the AI's behavior in unexpected ways. It really highlights just how sensitive these systems can be, doesn't it? So beyond just getting the results, why is documenting every single change so vital?
Because it builds institutional knowledge, it prevents you from repeating the same errors, and it ensures systematic long-term improvement. Simple as that.
Okay, now that we know how to set up the system, let's talk about the different measurement tools in your toolkit. Think of this like a doctor's diagnostic kit again. You wouldn't use a stethoscope to analyze a blood sample, right? You need the right metric for the right job, a specific tool for a specific problem.
That's an excellent analogy. First up, we have categorization metrics. Think of this as your stethoscope. This is perfect for tasks that involve putting items into predefined buckets like email tagging, content classification, maybe sentiment analysis. It works as a simple exact match comparison. Did the AI pick the right category, yes or no? Pretty straightforward.
Then there are correctness metrics. These are maybe more like a blood test. These are perfect for subjective, generative tasks, like evaluating the quality or factual accuracy of a written response. This is where you use that AI evaluating AI technique we just talked about. The evaluator AI provides an objective 1 to 5 score, perhaps, for the response's correctness and helpfulness. It adds that layer of objective judgment to inherently fuzzy tasks.
Next up, similarity metrics. Let's call this your MRI scan. This provides a deep, nuanced comparison. It's perfect for tasks where the goal is to match a specific style or tone or format. This metric measures how close the AI's output is to a known gold standard example from your dataset. It's all about stylistic adherence.
And finally, there are custom metrics. The specialist test, maybe. These are for any unique business-specific requirements that the standard metrics just don't quite cover. You define the criteria and the scoring system yourself, often by building out specific logic using something like an n8n code node, which is basically a small block of custom JavaScript right inside your workflow.
So why do we need so many different metrics, like a stethoscope versus an MRI scan?
It's simply because different AI tasks demand different diagnostic tools. Categorization is just a binary check, yes or no. Correctness is about subjective quality, but scored objectively. Similarity looks at stylistic nuance. Each one helps you understand a different dimension of your AI's performance. It allows you to accurately measure and diagnose its strengths and weaknesses.
Okay, cool. So you now have the core framework. Let's move into the professional playbook. Some advanced tips, troubleshooting, and a clear action plan that will really elevate your evaluation game. First, the pro-level playbook has 3 golden rules. The consistency principle is totally non-negotiable. Keep your evaluation model consistent across all tests. If you have an AI judging another AI, don't change the judge AI midway through your testing. If you do, all your comparisons become invalid.
Absolutely crucial. Then there's the documentation imperative. We talked about that lab notebook. n8n shows you the results, sure, but not what you changed to get them. A simple Google Sheet tracking your changes, hypotheses, and results is key to systematic improvement. It becomes your institutional knowledge base. And finally, the iteration strategy. Start small. Don't try to boil the ocean, maybe 10 to 20 examples just to validate your setup is working. Then scale up to 5,100 for more serious testing, and maybe 250 or more for production-ready systems. It's a gradual, deliberate climb.
Right. And of course, out in the field, you'll run into issues. It happens. So here's a quick field guide for troubleshooting some common things. If the built-in set metrics node is giving you errors or not doing what you need, try creating your own custom evaluation agent instead. You have that flexibility. If your evaluation results seem inconsistent run to run, you're almost certainly changing multiple variables at once. Remember the rule. Focus on one change at a time. And if your test data doesn't seem to reflect real-world results, your dataset probably isn't representative enough. You need to collect data over a longer period, maybe include more of those tricky edge cases.
This isn't just about tweaking your workflows a little bit better. This is fundamentally about transforming your entire approach to AI automation. The before state is guesswork, frustration, settling for good enough. The after state, it's data-driven decisions, continuous improvement, and a real durable competitive advantage. Faster optimization, better cost control, proven quality assurance. You actually know it works.
Whoa. Imagine scaling this precise evaluation method to hundreds of complex workflows across an organization, ensuring every single interaction is top tier, perfectly aligned with business goals. That's a massive competitive advantage right there.
So let's give you your mission briefing, a 7-step action plan to get you started today. 1. Choose your first evaluation target. Pick a workflow that's maybe almost good enough, but could be better. 2. Create a small test data set. 20 to 50 examples is fine to start. 3. Set up the basic n8n evaluation nodes to get your baseline measurement. 4. Run your first test and document that initial performance in your lab notebook. 5. Make one single change, just one. 6. Run the test again and compare the results, see what happened. And 7. Iterate and improve based on that data. And remember, you can often find complete workflow templates and even test datasets in online automation communities to help jumpstart your journey. Don't reinvent the wheel.
So thinking about all that, what's the single most impactful takeaway for someone looking to get started right now?
Start small with one workflow, build a small data set, and really commit to documenting every single change you make. That's the foundation. Today, we've walked through how to transform your AI workflow optimization process, moving it from an art of guesswork, really, to a science of data-driven decisions. It's a profound shift in mindset.
Yeah, from recognizing that medieval doctor problem to understanding the black box challenge, crafting those gold standard data sets and applying precise evaluation metrics, you now truly have the tools you need.
It's all about moving from, I think this works better, to, I know this works better, and here's the data to prove it. That evidence-based approach, that conviction based on facts, that's the real key.
So don't just hope your AI works. Start knowing it works. Pick a workflow, gather some data, and begin your first evaluation. The power is really in your hands now.
The difference between an amateur and a professional AI automator, it often lies squarely in this shift.
Yeah.
This is how you build AI systems that truly deliver on their promises. Systems you can justify, systems that give you a real, tangible edge.
Yeah, it's time to stop reading about it and actually start evaluating. Make that leap.
We really hope this deep dive has given you clarity and conviction. Until next time, keep digging, keep learning, and keep building smarter. Otiero Music.